Okay, section 3.2. First, let's start with turning to page 101 in your book and looking at the red box at the bottom of the page. It's the one with the multiplication and division properties of equations. I think that's what they do. 4 equations, to be technical about what they call them. Multiplication property for equations and division property for equations. Those are what you need to write in your book, in your notebook. And I want you to read with me really quick on page 101 because I want you to understand what it is you're writing down. So I'm going to read it so that you can see what each individual thing means, because I want you to eventually be able to understand how to read all this math-ese that we're learning. So it says, for the multiplication property of equations, for all real numbers, A, B, and C, that means it can be any number, A, B, and C. But A, B, and C have to probably be different numbers. That's why they're given different letters. So for any real number, A, B, and C, where C is not equal to 0, we'll talk about why C can't be equal to 0 in a minute. If A is equal to B, that means if you have an equation, A equals B, then AC has to be equal to BC. In other words, you can multiply by C on both sides. That's what it's saying. You can multiply by C on both sides, as long as C is not 0. Same thing down at the bottom. C can't be 0. C can't be 0 down at the bottom because then you would be dividing by 0. And you can't have a 0 on the bottom of your fraction, correct? Up at the top, in order to get rid of that C on both sides, you would have to divide both sides by 0. That's why C can't be 0. It could be any other number, just can't be 0, so you don't have to worry about the whole dividing by 0 part. Now, go ahead, take some time and write those two down in your notebook. Pause the tape while you do that. And then when you come back, we'll look at a few examples. I don't go anywhere while you pause the tape. I'm still here. It's exciting on this side, let me tell you. I've been through this before. I understand it already. That's why I'm on this side of the computer and not on that side of the computer. Yep. Okay. Oh, you want me to go ahead and do this so it's a shorter video? Because you like shorter videos? I understand that. I like shorter videos too. Okay, fine. So, when we go ahead and get to this, the whole point of what we just said was whenever you multiply or divide something on one side of the equation, you need to do it to the other side of the equation. You can't just leave the other side short. Whatever you do to one side, you have to do to the other side. One of the words they use in algebra is your equation has to stay balanced, because whatever you put on one side, you have to put on the other. Okay, so here for this one, I need to get the x by itself because they've asked me to solve. So I'm going to start by drawing my line. And I have to look at how this negative 16 is connected to the x. What is it that connects them? Is it added to it, subtracted from it, multiplied by it, or divided by it? And this one is multiplied. We know because there's nothing in between. So when there's nothing in between, it's always multiplication. And just like yesterday or section 3.1, we have to do the opposite to get rid of it. So since this is multiplied, the opposite of multiplication, because we have to break that bond, is division. So when you're in algebra and you want to write division, you always use your fraction bars. If I do it on one side, I have to do it on the other. Now, this is where a lot of people get mixed up, because they want to divide by 16. But I'm not trying to get rid of the 16. I'm trying to get rid of the negative 16, because I want to get rid of everything at one time. I don't want the negative to be left up there. So I'll do negative 16 on both sides. Everybody screams, but aren't we supposed to do the opposite? You are doing the opposite. The opposite of multiplication is division. So in order to get rid of whatever is multiplied, I have to divide. It doesn't mean we take the opposite of that number. Yesterday, or in 3.1, whenever you did it, the opposite of addition was subtraction, and the opposite of subtraction was addition. It wasn't just the opposite of the number, it just happens to look like the opposite of that number. So here when I do the opposite, I'm doing the opposite of whatever's tying it together, so we can break that bond. So now a negative 16 divided by a negative 16 gives me a 1. So I'm left with just that one x. So I can just write x is equal to 16 goes into 96 a lot of times. Grab a calculator, find out how many. Okay. So you said it goes in there 6 times. Positive or negative? I'm sorry, you're going to have to say it louder. You're a long ways away. Negative. That's good. Negative 6. I know I'm done because I have just a letter left. Over here, have x on top, 7 on the bottom. Still want to get the x by itself. How is the x connected to the 7? By division. But we want to break that. So I have to do the opposite of the division, which means I'm going to have to multiply by 7. When I multiply by 7 on this side, I have to multiply by 7 on that side. Now, does it need to be a negative 7? No, because we didn't say we wanted the opposite of this number. We want the opposite operation. So instead of the division operation, now we have a multiplication operation. This 7 cancels out with that 7, leaving me with an x equals negative 2 times the 7 gives me negative 14. Now, you may not like all that. You may not like it because it seems a little anti-intuitive. But I promise you, it is correct. I promise it is correct. So I need you to look at a harder problem. And if you need to go back and look at those two while you're doing your homework, I understand. Because it's kind of anti-intuitive, like I said. But we need to look at a harder problem. Two over 3x is equal to 10. Now I know you're saying this isn't that difficult for me, but there are 2 different ways you can do this, and I need you to pick whichever one you like best. I don't care which one it is. It's entirely up to you. This is your choice. So if you look at this and you say, oh, that's a fraction times x, fine, good, and wonderful. And you say, since the fraction is multiplied by x, that means I need to divide both sides by a fraction. Fine, good, and wonderful. Then you have to remember that multiplying by a fraction is just like, dividing by a fraction is just like multiplying by the reciprocal. So I have to multiply by the reciprocal on both sides. All of a sudden this looks a little more cumbersome and not so fine, good, and wonderful, but okay. So the 3's cancel each other out, the 2's cancel each other out, and you're left with just x. Over here, you have a whole number times a fraction. When you multiply a whole number by a fraction, there are 2 different ways you can do that. You can say multiply by the top one and then divide by the bottom one, or you can say let's divide by the bottom one first and then multiply that answer by the top one. Or if you really want to go to a whole bunch of trouble, you could write it out. You're probably going to think, well, why don't I just stick it in my calculator? And that's fine, good, and wonderful too. But, comma, really need to know so that you don't have to always stick stuff into your calculator, a faster way of doing it. So, you can either multiply by the top, divide by the bottom, or divide first and then multiply. If I multiply first, I'd say 10 times 3 is 30, divided by 2 is 15. If I divide first, you end up with smaller numbers, so it might be easier to divide first. I divide 2 into 10, which is 5, and then 5 times 3 is 15. Either way, you're going to end up with x is equal to 15. Now, you're thinking, you said there were 2 methods, and we just did 2 methods, but wait, there's more. That was one way of doing it, where you multiply by the reciprocal. Sometimes you're going to look at this and you're not really going to see a fraction times an x. What you're really going to see is 2x divided by 3 is equal to 10. Because they said the same thing. The x can either go beside it or it can go on top of it. Says the same thing. So if you look at it and you see this instead, then you're not going to think, oh, let me just multiply by the reciprocal. Instead, you're going to think, now I got to get rid of 2 things. When you do this, you always need to get rid of the bottom thing first. So you can multiply both sides by 3. That makes it 2x is equal to 30, and then divide both sides by 2 and get that x is equal to 15. Either way, you still get the x is equal to 15, but if you do it enough, I mean, like once you do a whole bunch of problems, like say 3 months down the road, you're going to be more comfortable with this way than you will with this way, even though you've always done it this way. Because you'll just start seeing stuff as being on top and on bottom, and then I got to get rid of this before I get rid of that, take care of this, and everything's fine, good, and wonderful. So kind of be careful right now about what you're looking at and making sure you're doing the opposite of whatever you see. And that'll help you decide which one you should do first. So let's talk about classwork. Number 1 through 6 all in the class exercises. And then the homework is practice exercises. Numbers 1 through 21 odd. Not nearly as many problems as I could give you. But that's because I really want us to get to the next section where I'm going to load you up with a whole bunch of problems. So make sure you catch up on all your homework tonight, so tomorrow you won't be quite as frustrated. Okay, bye.